Hey guys, so today we are going to try to understand the Born-Haber cycle. Let's get right into. So I hope you remember about the lattice energy, and if you don't, well, it is the energy change that occurs when 1 mole of ionic solid dissociates into 1 mole of its gaseous constituent ions. Now, so how do we calculate this? What should be the lattice energy for sodium chloride? How do we find out that? Now, one way is to determine it experimentally, and that is a little bit more tedious. The other way is to actually look into the formation of NaCl itself and see if we can find a loophole. So, how does NaCl forms actually? So there's one reaction that is very direct, that is sodium and chlorine, sodium solid, chlorine gas, they combine and give you sodium chloride. That's one way. That's the direct way. What's the more detailed way for this to happen? Well, sodium solid converts into sodium gas. So I will say sublimation of sodium happens. Then I can say that chlorine, a molecule, must also dissociate into gaseous chlorine atoms. So I should say dissociation of chlorine gas, chlorine molecules happen, and then I will say that sodium loses 1 electron to form Na plus, chlorine gains 1 electron to form Cl minus. They come together, right, and then finally they form the solid NaCl. And this last step, so let's number the steps. So 1, 2, 3, 4, and this last step, fifth step, is the actual step that will give us the lattice energy, right? So we want this. This is what we want to find out. Now, experimentally, you can determine what energy is required for formation of NaCl, or released. In this case, it's released, right, for NaCl. So this delta H, the enthalpy change, equals to, so delta H is minus 411 kilojoule per mole. Now, there's a very beautiful law that is going to help us with this, and that is the Hess's law. Now, what does Hess's law says? That if a chemical reaction is a multi-step process, then the total energy change must be equal to the sum of individual steps. So, if you know the total energy change that is going to happen throughout the chemical reaction, then it must be the sum of the individual steps involved here, right? So, well, as it happens, we have the total energy change with us, that is minus 411 kilojoule per mole. If somehow we can get all the remaining steps, the energy change that accompanies all the remaining steps except the lattice energy, we can do the maths, right? So let's get into it. Let's try to find out what should be that. So very first is conversion of sodium, that is solid, into sodium, that's gas. As it happens, this delta H is equal to minus 108 kilojoule. That's okay, sorted. Well, half chlorine gaseous molecules need to dissociate, right? So 1 mole of chlorine atoms, gaseous atoms, how much energy is involved here? So that's 120 kilojoule. So we have all of these data from the experiments. So I'm not just saying it out. Actually, this is all from the experiments. Now, sodium again needs to lose the electron. So let's say sodium loses 1 electron to form Na plus, and this again has an energy associated 496 kilojoule. Remember, to pull out an electron, you need to provide energy. Cl, and again, needs to gain this 1 electron. So again, this is not going to be an easy task. You again need energies, right? So that's minus 349 kilojoule. Now you must be wondering one key thing here. Why here I have written 496, whereas in the case of chlorine I have written minus? Why is the negative value? That's because when you pull out an electron from sodium, the mixture of sodium and electron is actually higher in energy level. You are increasing the energy level of the system. On the other hand, when you add one electron to the chlorine, you are reducing the energy of the system. That is why minus. But even if you do this sum, you still will see, let's just do it for understanding's sake. 108, 120, 496, 8614, well, 9312, 21, 4, 5, 6, 7, 724, and 349, right? You see, still we have a positive value. That means still sodium chloride formation is not enough. It still requires energy. That means it shouldn't be a process that will that's cool to happen, right? And that is why comes the last step of the reaction, where Na plus and chlorine minus ions, they come together and form the NaCl lattice. And this delta H5, the change in enthalpy, is your lattice energy, right? And we are going to give this negative because lattice energy is actually the energy that is needed to break the lattice, right? And here this energy is being released, right? Now the Hess's law says, well, the sum of all these energies is going to be, if you remember, let's go, minus 4.11, right? So minus 411, and let's equate all of this. So that comes to be 375 kilojoule minus U gives you minus 411. Now if you calculate for U, you get 375 plus 411 equals 786 kilojoule. This is your lattice energy, right? Now I hope you remember that the entire topic was Born-Haber cycle. Now why? Because this entire scheme of calculation was devised by Max Born and Fritz Haber based on Hess's law. That is why we call this Born-Haber's cycle, right? Where we use the individual reactions to find out the value of lattice energy. I hope this makes sense.
We hope this video was helpful. To see more biology topics covered, click on our channel and don't forget to subscribe.